Hello, this is Mr. Cerisa, and this is a very special episode. This will be for 10-4. The question is number 75 on page 672. So a lot of people were struggling with that one. First thing, make sure you set it up correctly. So this says that some nuclear power plants utilize a natural draft cooling towers in the shape of a hyperboloid. And a hyperboloid is, so if you have a hyperbola, and it's rotated around this conjugate axis here, you'll form a three-dimensional object. So this is really big in calculus, taking a two-dimensional object and rotating it around an axis, and then you get a three-dimensional object. So make sure you know how to do this. And essentially, if it's rotating around here, then this is more or less what it'll end up looking like, is this hyperboloid. So they're saying that the cooling tower has a base diameter of 400 feet, and so this has a base. I didn't draw this to scale. So the base is 400 feet, which means it's 200 and 200 on each side of the conjugate axis. And then at the narrowest point, 360 feet above ground. So that will be how tall this side will be. So 360 feet. And it has a diameter there at 200 feet. So this whole thing is 200, which means 100 and 100. And then finally, it says if the diameter at the top of the tower is 300 feet, so here's 300, and so of course 150 and 150. Oops, that's a horrible 150. They want to know how tall the tower is, so from head to toe. How tall is this? Alright, so let's set up the problem. There's tons of information here, so let's figure out where we're going to start. The first thing I would do is say, okay, we set up our center at the origin, and it's a hyperbola, so we're set there. Now we have to find out what a squared and b squared are going to be, and of course that whole thing equals 1. So the quickest one is going to be the a, because they have the vertex going through the axis there, and that's at 100, so that means a equals 100. Alright, that was easy. B is from finding out the slope, and we're not going to given any of that information. And C is found from the focus, and we're not given any of that information. So all we have left is our x and our y. So after I exhaust the a, b, and c part, I start looking to see if there's some point on this hyperbola that I know. And I do. So I know this point right here is going to be 200, and then it's down 360. And so that's my x and my y. And so here's x and y. And so I take my 100 and I plug it into A. Take my x and go in there, and my y, and it goes there. So let's start doing that. So 200 squared over 100 squared minus negative 360 squared, and that's over b squared, equals 1. So now you can see b is the only thing that we don't know. So let's figure that out by solving for b. And so this is kind of complicated. I'm going to subtract over that, subtract over this 200 squared over 100 squared. And then I'm going to multiply or divide. I'm going to take this and divide it by this part. So that's a negative 360 squared. And then what I'm left with now, I have a 1 over b squared equals this big mess that I just made. 1 minus 200 squared over 100 squared all over the negative of the negative 360 squared. And so from here, I'm going to do the inverse. So that -1 symbol, if you remember, taking something to the -1 power is really just making the reciprocal of that. But there's a key on your graphing calculator that does that. So I'm just using my graphing calculator, and I put in everything on the right side exactly how I see it, with all the parentheses how I see it. And when I do that, I get back 43200, and I don't need to take the square root of that because all I'm doing is putting that into the denominator over here. So what I'm going to do now is just rewrite this equation with my new numbers that I have. And so, let's see. So I'll have an x squared over my 100 squared, and that's minus y squared over 43200, and that equals 1. So we're not done yet. Okay, so this is actually a pretty big problem. I wish I wrote a little bit smaller. So now we need to see how high the tower is. And what we do know is that the diameter at the top of the tower is 150 feet. So I'm going to take that 150 feet and plug it in for x, and then I'll have to solve for y. So I'll do that right now. Alright, so 150 squared over 100 squared minus y squared over 43200 equals 1. And then I'll subtract over that 150 squared over 100 squared. I'll multiply that whole thing by negative 43200. And then, so that gets rid of this I subtracted, this I multiplied by, and then I just need to take the square root of this whole thing, and I'll end up with a y. And so if I plug in all that into the calculator exactly how I see it, I'm going to get 232.37. And you might be saying, well, that's not the answer in the back of the book. And of course not. That's just the amount that's above the transverse axis. So you still have to add the 360 feet that the transverse axis is above the base. All right, so if we look at our graph here, that we have 360 plus the 232.37. So we have to add those two up. And when we do that, we get 592, and I'm going to go with 0.4 because they don't specify how many places to go out, so feet high. Alright, there we go. I hope that this helped, and thank you very much.